section, we will study composition of functions and the inverse of a bijective function. Consider the set A of all students who appeared in class 10 CBSE board examination in 2020. Each student appearing in the board examination is assigned a roll number by the board, which is written by the students in the answer script at the time of examination. In order to have confidentiality, the board arranges to deface the roll numbers of students in the answer script and assigns a fake code number to each roll number. Let B subset of N with a set of all roll numbers and C subset of N with a set of all code numbers. This gives rise to two functions, fmaps A to B and gmaps B to C, given by f of A equal to the roll number assigned to the student A and G of B, the code number assigned to the roll number B. In this process, each student is assigned a roll number through the function f, and each roll number is assigned a code number through the function G. Thus, by the composition of these two functions, each student is eventually attached a code number. This leads to the following definition. And G maps B to C be two functions, then the composition of f and g denoted by gof is defined as the function gof A to C given by gof of x is equal to g of fx for all x belongs to A. This can be understood with the help of this given diagram. Here, set A element is x, which goes to element fx of set B with the help of function f, and the fx element fx goes to set C and becomes g of fx with the help of the function g. And the composition function is gof, which sends the element x to g of fx. Let us take an example. Find gof and fog if f maps R to R and g maps R to R be given by fx is equal to cos x and gx is equal to 3x square. Show that gof is not equal to fog. Here it is written, you see, we have gof x is equal to g of fx, which is equal to ultimately g of cos x equal to g of cos x whole square equal to 3 cos square x. Similarly, fog x is equal to f of g x, which is equal to f of 3x square, which is equal to cos 3x square. Now note that 3 cos square x is not equal to cos 3x square for x not equal to 0, hence gof is not equal to fog. Show that if f maps R minus 7 by 5, that means from real number set of real numbers, the 7 by 5 is excluded, to R minus 3 by 5 is defined by fx equal to 3x plus 4 divided by 5x minus 7, and g maps R minus 3 by 5 goes to R minus 7 by 5 is defined by gx is equal to 7x by 4 divided by 5x minus 3, then fog equal to IA and gof is equal to IB, where A is equal to R minus 3 by 5 and B is equal to R minus 7 by 5, where IA of x is equal to x for all x belongs to A, IB x is equal to x for x belongs to all x belongs to B, are called identity functions on set A and B respectively. So here I have worked out the example. So you see here gof x is equal to g of, in place of fx we have substituted 3x plus 4 divided by 5x minus 7, and similarly again we have substituted in place of gx is given as 7x plus 4 divided by 5x minus 3. So in place of 7x, this x is substituted by 3x plus 4 divided by 5x minus 7. So 7 of 3x plus 4 divided by 5x minus 7 plus 4 divided by 5 into 3x plus 4 divided by 5x minus 7 minus 3. So which ultimately after simplification we get the x. So after simplification we get it is equal to x. Thus of x is equal to x for all x belongs to B and fog x is equal to x for all x belongs to A, which implies that GOF is equal to IB and fog is equal to IA. One more example, show that F maps A to B, G maps B to C are 1, 1, then GOF A to C is also 1, 1. So it is very straightforward proof. You just see GOF of x1 is equal to GOF of x2 implies G of fx1 is equal to G of fx2, which implies fx1 is equal to fx2 since G is 1, 1. This implies x1 equal to x2 as f is 1, 1. Hence, GOF is 1, 1. As GOF x1 is equal to GOF x2, we have concluded that x1 is equal to x2. From definition of 1, 1ness, we got that GOF is also 1, 1. Work out here. Show that if F maps A to B and G maps B to C are onto, then GOF A to C is also onto. And another example, consider the function f and g such that composite of GOF is defined and is 1, 1. Are f and g both necessarily 1, 1? So answer is no, they are not necessarily 1, 1. Here GOF is 1, 1 but G is not 1, 1. We have proved here with the help of this example. And another, are F and G both necessarily onto if GOF is onto another question? So the answer is again no. It can be seen that GOF is onto but F is not onto. And now one remark also, you can remember this result. It can be verified in general that GOF is 1, 1 implies that F is 1, 1. Similarly, GOF is onto implies G is onto. Inverse of a function. So definition is written here. A function f maps x to y is defined to be invertible if there exists a function g maps y to x such that GOF is equal to ix and fog is equal to iy. The function g is called the inverse of f and is denoted by f inverse. Thus, if f is invertible, then f must be 1, 1 and onto, and conversely, if f is 1, 1 and onto, then f must be invertible. This fact significantly helps for proving a function f to be invertible by showing that f is 1, 1 and onto, especially when actual inverse of f is not to be determined. Of course, we can use this process for finding inverse as well. So here I have worked out one example for you to just see. Let f maps n to y be a function defined as fx equal to 4x plus 3, where y is equal to y belongs to n, y equal to 4x plus 3 for some x belongs to n. So that f is invertible, find the inverse. So it is worked out here, you see. Suppose we consider this fx1 is equal to fx2, so this implies 4x1 plus 3 is equal to 4x2 plus 3. So this implies ultimately x1 is equal to x2, so hence f is 1, 1. And for proving 1, 1, we consider one arbitrary element y belongs to y. Then y is obviously of the form 4x plus 3 for some x belongs to domain n. So this implies x is equal to y minus 3 by 4. Range y, there exists x belongs to domain n such that f of x is equal to f of y minus 3 by 4, 4 into y minus 3 by 4 plus 3 is equal to y. Hence f is onto, thus f is invertible with f inverse x equal to x minus 3 by 4. Here why we have written f inverse x equal to x minus 3 by 4? Because we have got earlier, x is equal to y minus 3 by 4. There we have replaced y with the x, and we got f inverse x is equal to x minus 3 by 4.